Bawat bata may tanong,
Ba't ganito? Ba't ganon?
hayang buksan ang isipan.
Sa tronics at agham, tayo na sa mapua. Tuklasin natin ang elektronika.
Buksan ang pag-iisip,
Tayo'y likas na engineer. Tayo na sa mapua. Tuklasin natin ang elektronika. Kinabukasan ng ating bayan, siguradong makakamtan.
sa daigdig ng agham, tuklasin ang kaalaman.
Halina't lumipat sa daigdig ng isipan.
Tayo na
Sa mapua, tuklasin natin ang elektronika.
buksan ang pag-iisip,
Tayo'y likas na engineer. Tayo na sa mapua. Tuklasin natin ang elektronika. Kinabukasan ng ating bayan, siguradong makakamtan.
Oh, bakit ngayon ka lang?
Ano po kasi? May exam po kami sa Tronics. Nag-group study po kami ng mga kaibigan ko sa bahay nila. Kasi si Ma'am Chan nung nagturo, di ako masyadong nakinig. Di ako nakinig sa klase niya.
Sinong Cha?
Si Ma'am Cha, Ma'am Charmaine Paglinawan.
Ah, pagkakatanda ko, mag-aaral pa lang ako sa Mapua. May chairman din ako klase. Kaso Cabrera apelyido niya. Siya yung number 1 crush ko nung college. Kasi ang cute-cute niya, tas ang bait-bait nun eh. Pagkakatanda ko, una kami naging magkaklase sa electromagnetic, tapos si Sir Ernesto Vergara yung prof. Nagtuturo pa ba sa Mapua yun? O ano ba yung examin niyo bukas? Ba't di ka pa nag-aaral? Saan ka ba nahihirapan?
Dads, nahihirapan po ako dun sa yung tinuro nung last lecture ni Ma'am Pagli. Kasi, di ako masyado nakinig nun eh. Ang pagkakalam ko lang nun, yung Zener diode lang yung alam ko, tas yung the rest ng lecture, hindi ko na alam. Tapos yung exam namin is tungkol sa special purpose diode.
Special diodes? Tamang-tama, pinag-aaralan ko din yan eh. Kasi kailangan sa work. Kumuha ka ng ballpen at papel.
Ito,
Tuturuan
tingnan
kita.
mo. Yung ginawa kong presentation, makinig kang mabuti.
Special diodes. Shukti diodes. History. Though the invention of the Shukti barrier and diode are often attributed to Walter H. Shukti, he did not actually create the electronic components. Shukti was a German physicist working in Berlin in the early 1900s. He developed a formula for the interaction energy between a point of charge and a piece of metal. This formula eventually led to the creation of the barrier and diode that bear his name. Definition: Shukti diodes are constructed of a metal-to-end junction rather than a p-n semiconductor junction. It is also known as hot carrier diodes. Shukti diodes are characterized by fast switching times or low reverse recovery time, low forward voltage drop or typically 0.25 to 0.4 volts for a metal-silicon junction, and a low junction capacitance.
Applications: RF mixer and detector diode. It has come into its own for radio frequency applications because of its high switching speed and high frequency capability. Power rectifier. Their high current density and low forward voltage drop mean that less power is wasted than if ordinary p-n junction diodes were used. Power or circuits. One example may be a mains power supply and a battery supply. In these instances, it is necessary that the power from one supply does not enter the other. Solar cell application. Solar cells are typically connected to rechargeable batteries, often lead acid batteries because power may be required 24 hours a day and the sun is not always available.
Pin diode. Definition. A pin diode obeys the standard diode equation for low frequency signals. At high frequencies, the diode looks like an almost perfect or very linear, even for large signal resistors. There is a lot of stored charge in the intrinsic region. At low frequencies, the charge can be removed and the diode turns off. At higher frequencies, there is enough time to remove the charge, so the diode never turns off. The pin diode has a poor reverse recovery time. The wide intrinsic region also means the diode will have a low capacitance when reverse biased.
Applications: RF and microwave switches. Under zero or reverse bias, a pin diode has a low capacitance. The low capacitance will not pass much of an RF signal. RF and microwave variable attenuators. By changing the bias and current through a pin diode, it's possible to quickly change the RF resistance at high frequencies. The pin diode appears as a resistor whose resistance is an inverse function of its forward current. Photodetector and photovoltaic cell. Pin photodiodes are used in fiber optic network cards and switches as a photodetector. The pin diode is reverse biased. Under reverse bias, the diode ordinarily does not conduct. The pin photovoltaic cell works in the same mechanism. In this case, the advantage of using a pin structure over conventional semiconductor junction is the better long wavelength response of the former.
Step recovery diode or snap diode. History. The first published paper on the SRD is Boff, Moll, and Shen, year 1960. The author starts the brief survey stating that the recovery characteristics of certain types of PN junction diodes exhibit a discontinuity which may be used to advantage for generation of harmonics or for the production of milli-microsecond pulses. Definition. In electronics, a step recovery diode is a semiconductor junction diode having the ability to generate extremely short pulses. They also refer that they first observed this phenomenon in February 1959.
Application: a COM generator. A generator of many harmonics. Moderate power of 2 times and 4 times multipliers are another application.
Ay, ganun lang pala yun. Napakadali naman. Kala ko, kasi special purpose diode, Zener diode lang meron. Meron pa palang LED, varactor, tunnel diode, at marami pa palang iba na pwedeng i-special purpose diode.
Oh, sige na. Kumain ka muna. Hanapin ko pa yung iba. Madami-dami pa to.
Sige dad, pasok na po ako, malilate na po ako, may exam pa po ako eh.
Uy, teka lang, saglit. Tuturo pa ako sa'yo. Saglit lang to. Halika dito.
Tunnel diodes. History. It was invented when he was with Tokyo Chushin Kogyo, known as Sony. Tunnel diodes were first manufactured by Sony in 1957, followed by General Electric and other companies from about 1960, and are still made in low volume today. Definition. A tunnel diode or Isaki diode is a type of semiconductor diode that is capable of very fast operation. Well, into the microwave frequency region by using the quantum mechanical effect called tunneling.
Application. Due to the tunneling mechanism, it is used as an ultra-high-speed switch. The switching time is of the order of nanoseconds or even picoseconds. Due to the triple value feature of its curve from current, it is used as a logic memory storage device. Due to extremely small capacitance, inductance, and negative resistance, it is used as a microwave oscillator at a frequency of about 10 GHz. Due to its negative resistance, it is used as a relaxation oscillator circuit.
Laser diodes. History. Coherent light emission from a semiconductor or gallium arsenide diode. The first laser diode was demonstrated in 1962 by two U.S. groups led by Robert N. Hall at the General Electric Research Center and by Marshall Nathan at the IBM T.J. Watson Research Center. The first visible wavelength laser diode was demonstrated by Nick Holonyak Jr. later in 1962. Definition: it is an electrically pumped semiconductor laser in which the active medium is formed by a p-n junction of a semiconductor diode similar to that found in a light or emitting diode.
Applications. RF mixer and detector diode. The Schottky diode has come into its own for radio frequency applications because of its high switching speed and high frequency capability. Power rectifier. Their high current density and low forward voltage drop means that less power is wasted than if ordinary p-n junction diodes were used. Power or circuits. One example may be a mains power supply and a battery supply. In this instance, it is necessary that the power from power supply does not enter the other. Solar cell application. Solar cells are typically connected to rechargeable batteries, often lead-acid batteries, because power may be required 24 hours a day, and the sun is not always available. Clamp diode. Clamp diode, especially with its use in LSTTL, Schottky barrier diodes may also be used as a clamp diode in a transistor circuit to speed the operation when used as
Sige
a
dad,
switch.
pasok na po ako. May exam pa po ako, malilate pa po ako.
O sige, ano oras na rin, papasok na rin ako sa work eh. Good luck sa exam mo. Sana may pasa mo.